So basically now we will look at the cases. So in my previous video I discussed the introduction of this. So now let's discuss the cases, right? So number one case which we have is basically when the acceleration is equal to 0. It means that the body is either in rest or in uniform motion, right? Either the body is in rest or a uniform motion. Okay, let's take an example over here. Consider that this is a container or a pot, whatever. Okay, the man is sitting inside it. Okay, this is basically a man, right? And the acceleration is basically equal to 0, right? And we are assuming that the basically this body is in rest. Okay, when the body is in rest, it means the apparent weight and the real weight must be equal to 0. Let's consider the force is equal to, as I guess the weight will be higher. So we will write over here weight minus tension, right? When tension is in negative, so it will go over there, and it will, okay, when the acceleration is 0, right? We will put the formula of F, which is basically F is equal to ma, and here we have W minus T, right? So we have said the expression is 0. So 0 multiplied mass will be 0. It will be 0 is equal to weight minus tension, right? Now this tension is of negative. It will go there and it will be positive. Tension will be equal to weight, right? So we can easily say that when a body is in rest or in uniform motion, the apparent weight is equal to the real weight, right? We can write over here that when the body is in uniform motion or rest, when the body is in uniform motion or rest, the real weight is equal to weight apparent weight, right? So when the body is in uniform motion or rest, the real weight is equal to the apparent weight, right? So I hope this is clear to you. Now let's look into the second case, which is basically, okay, let's look into second case when, okay, let's make container over here. Okay, it's our container. Let's draw a body over here. Okay, consider that the body is going upward. The body is going upward. So it means that the tension is greater than the weight. It means the apparent weight is greater than the real weight. So we can easily write over here force is equal to tension minus weight. Okay, basically here acceleration is not equal to 0, right? So this is force. Force is equal to ma, and tension will remain same, and W will become mg. Now this ma will go there and it will be like ma plus mg is equal to tension, and then this tension will be equal to, now we will take common, right? So mass is common here, it will be m a plus g, right? So this will be formula. This apparent weight will, the apparent weight, the acceleration plus the gravity both will join together, and then the tension apparent weight will be formed. So we can say over here the apparent weight is greater than the real weight. The apparent weight is greater than the real weight, right? So we can write this formula as this 2, tension is equal to ma plus w. We can write this formula as this, and we can say that tension, which is apparent weight, is greater than the real weight, right? It will be like this. So I hope this is clear to you. So now let's look into the third case. So here we have the third case. I should make this so again. Let's make a body. Here is a man. This is a man basically, and the acceleration is not equal to 0. The acceleration is not equal to 0, and the body is moving downward. The body is moving now downward. It means the real weight is greater than the apparent weight because the body is moving downward. So we can write over here F is equal to weight minus tension, right? So over here this tension will go there, and it will like tension will be equal to weight minus force. It weighs the, in this apparent weight, the real weight will get subtracted from the force applied. So it means over here that the apparent, okay, the real weight is greater than the apparent weight, right? This is like this. Let me write over here the real weight is greater than the apparent. The real weight is greater than the apparent weight, right? Okay, now let's go into the fourth case, which is okay. Now basically this is of free fall motion. This is, for example, there's a body and it has jumped from a hill or something and it is coming downward, and this is basically the free fall motion. It means when the body is in free fall motion, the acceleration is equal to gravity, right? So it means obviously it is coming downward, so the weight will be, the real weight will be greater than the apparent weight. It will be like this. We know that F is equal to ma, right? And this W is equal to mg, and this is minus tension over here, right? Now we know the acceleration is equal to gravity, right? And there's no kind of tension over here. Is something applying tension over here? Is there any normal reaction? No. So it means the tension will be equal to 0. Tension will be equal to 0. And we know the gravity will be equal to acceleration. So both will be equal, right? Gravity is what? The gravity, acceleration is equal to gravity over here, and tension is equal to 0. So here minus will be neglected and 0 will put. So it means the tension will be basically 0. Now what is tension? Tension is basically the apparent weight, right? When the body is in free fall motion, the acceleration is equal to gravity and the tension is equal to 0. It means apparent weight is 0. And when the apparent weight, the weight we feel is 0, this condition is basically known as weightlessness. This is known as weightlessness when the apparent weight is equal to 0, right? So I hope this is clear to you. If you have any kind of query, you can ask me in the comment section. I'll be very glad to answer you guys.